Hello, Nick Leifiker here, and welcome to week 3 of Operations Management 409. What we're going to talk about this week is, well, last week we talked about processes, how to get stuff done. That said, sometimes with processes, sometimes we deal with things that are too big to handle with your typical process, and that is, well, a project. So how do we deal with big things? How do we deal with getting large projects done? And that's largely the goal of talking about this week. How do we manage a project? How do we manage these large tasks that oftentimes have to be done with regard to a business? So, to illustrate this, well, there's a really good example. Not sure how many of you are familiar with the Beatles. Hopefully you are. But, well, let's talk about a project that the Beatles came up with toward the end of 1968, early 1969. Initially it was called Get Back, because that's what they wanted to do. They wanted to get back to their roots. They wanted to get back to the sound that made them famous back in the early 1960s. So to that end, they started writing material and started recording in 1969, early 1969, and this included several live performances. After all, there were great leaps with regard to technology between the early 1960s and late 1960s, so they wanted to get back to that early feel of early 1960s recording, and that included live performances, because in the early 1960s, oftentimes the difference between a live recording and a studio recording was where it was done. By the late 1960s, on the other hand, you could record each track, each instrument, and then mix and match as needed. That said, well, the Beatles of the late 1960s were not the Beatles of the early 1960s. The Beatles of the early 1960s were two dominant personalities in John Lennon and Paul McCartney, and two more laid back, more introverted personalities in Ringo Starr and George Harrison. However, by the late 1960s, Harrison had become a well-renowned musician in his own right and wanted more creative say in the affairs of the Beatles. Ringo was starting to wonder if everyone was starting to leave him behind. And then, of course, John Lennon had Yoko Ono. And the less said about that, the better. So the band was in the process of breaking up. The band was breaking up as this album was being recorded. So they finished the tracks. Then, well, they went on to another project, one last swan song, if you will, called Abbey Road. And then they broke up in early 1970. However, they had all this recorded material. So what do you do with this recorded material? They didn't know what to do. They just felt like shelving the project, getting rid of it, just putting it aside. The problem is, well, the movie had already been released, so people already knew about this music, so the music effectively had to be released. So, what do you do? What eventually happened is that the Beatles effectively turned to one of the other great innovators of the 1960s, a guy by the name of Phil Spector. Now, Phil Spector is almost the prototype of that old saying that there's a fine line between genius and madness. This guy he had his issues, and in fact, he's currently serving time in prison for those issues. However, in the 1960s, he was probably the best sound engineer on earth. Working with bands like the Crystals, the Ronettes, the Righteous Brothers, well, he developed a music mastering technique known as the wall of sound. In other words, he was good at producing very good albums. And because of this, what ended up happening was an album that tried to emulate the early 1960s sound didn't, because, well, Spector brought in his techniques to produce and master this particular album, to take the recorded material and turn it into a finished product. So the project was done. The project was completed. But it wasn't what the Beatles had initially hoped for when it came to the finished product. So now what? You had a finished good. That said, well, the reaction from the Beatles, the people who were hoping to have this project done, was somewhat mixed. Paul McCartney hated it. He was not happy with the final result, so much so that in 2003 he eventually took those old recordings and mastered his own version called Let It Be Naked. John Lennon, was a little more philosophical about things. He pretty much said that he was just amazed that someone had been able to take those recordings, take that stuff, and keep in mind, stuff was not the word he used. The word he used was somewhat more pithy. He was just amazed that someone had been able to take those recordings and make an album out of them. So, what's the moral of the story here? The moral of the story is that if you're not careful in managing a project, if you're not careful in seeing a project to its completion, the project may go in a direction that you don't expect, as we see with Let It Be, or it could simply be unfinished entirely. The history of music is filled with albums that were never completed or never released. So, the lesson here is this. When we manage a project, we have to be sure that we're able to get this done so that it's managed on time, that it's managed according to certain rules, and that we effectively keep the goal in mind. We keep the finished product in mind. Because, after all, when we have a project, we want this vision. We want this completed project done, this completed item done. So, if we need to manage projects like this, well, what is a project? A project is big things that need to be done. A project is generally something we do once. It has considerable costs in terms of money and time and resources. Oftentimes there's a deadline involved, so it has to be completed within a limited time. And generally, there's stuff that needs to be done. So there's a set of tasks, a set of activities that must be performed. So projects, in many ways, are processes, just writ large and done once. Now, when it comes to these things, there's a few things that I want you to think about, want you to remember. As mentioned before, I don't want memorization. I don't believe in memorization. In today's society, memorization is pretty much superfluous. However, I do want familiarization. So, a few things to be familiar with, a few things to remember as we go through this chapter. First, go forward through the path, then backwards. What does this mean? It means that when we calculate the earliest start and earliest finish, we go forward through the project. And then once we've done that, once we've determined how long a project takes, we go backwards through the project to find the latest finish and latest start. So when we're calculating the earliest start, earliest finish, and latest start, latest finish for using PERT CPM, and we'll talk about PERT CPM later, we go forward, then backwards. Second, the critical path almost always determines everything. Well, I'll talk about critical path in more detail later, but the critical path is effectively the set of tasks that usually determines how long a project takes. Now, it's important to note that this almost always determines everything. The reason why is because in cases where we have variation, where we have uncertainty in how long tasks take, sometimes a non-critical path may end up being the set of tasks that determine how long a project takes. So we have to be aware of that. So going on, when we have uncertainty in the tasks, we go with the mean and not the expected time. what does this mean? When we handle PERT CPM with uncertainty, we'll have a minimum time, in other words, how long we expect things to take if everything goes well, a maximum time, how long we expect things to take if everything goes wrong, and an expected time, how long we actually expect it to take. Well, we have a formula that we'll use to convert those estimates into a mean task time. In other words, how long on average this task will take. So when we use PERT CPM with uncertainty, we want to put in those mean task times and not just stick with the expected completion time. Going on, standard deviations don't add, variances add. So what does this mean? When we add things together, we add results together, oftentimes those results will have some uncertainty, some variation involved with them. So that means that you have a mean, you have a standard deviation. Well, when you add things together, suppose you add A and B together. Well, A plus B is, of course, A plus B. However, the standard deviation of A plus the standard deviation of B is not the standard deviation of A plus B. However, the variance of A plus the variance of B is the variance of A plus B. So this is how we combine variances. This is how we combine variation for items that we're adding together. We don't add standard deviations, we add variances, and the variance is simply the square of the standard deviation. And then finally, when using a normal chart, and standard normal charts near the back of the book, I believe page 408 and 409 if I recall correctly, it's important to remember that the z-values are along the tops and the sides, and the probabilities are in the middle. So at several points in this course, you'll be asked to convert z-values to probability or convert probability to z-value. So it's important to know how to use a standard normal chart. For crashing, and we'll talk about what crashing is later, we search for bargains. In other words, we want to crash the task that is on the critical path, because only helping the critical path will decrease the time to complete the project. But we want to crash the one that has the smallest crash cost per unit time, or crash cost per week, if you will. So we search for bargains. In other words, what gets us the most for our money. Then finally, there's formulas for calculating the mean and variances for each step of the project when we have uncertainty, variation in the project. So that mean time is just the minimum plus 4 times the expected plus maximum, all divided by 6. And that's always divided by 6. It's not divided by 7. It's not divided by 23. It's always divided by 6 in that case. And the variance is the maximum minus the minimum. That difference, you square that, and you divide by 36. And that's always divided by 36. And it's these means and these variances that we're going to use to determine the mean project completion time and ultimately the standard deviation of the project completion time. We're working with PERT CPM with uncertainty. So, remember, projects, these are things that we might do once. So they're unique events, and they're used to accomplish a set of objectives. To build the business building, for instance, that was a project. To build a ship, for instance. Now keep in mind, sometimes you may need to convert a project development to a process. This happened in World War II, for instance. Like I said, the building of a ship, a large sailing vessel, is generally a major project. However, due to the necessities of World War II, that so many cargo vessels were needed that the building of ships, of cargo ships, was effectively turned into a process. In other words, you took the normal shipbuilding process, which again at the time was a large project, and you converted it to a more automated process. Sometimes that's necessary, sometimes that happens. So again, with projects, in general, these are one-time operations to accomplish a set of objectives. And like I said, a project is just a really big process. And in some cases, you have to convert it to a process. That said, projects are generally far more expensive than your standard process. Rather than make 1,000 items per day at $1 each, you make one item in 6 months that costs $100,000. So you have a large number of activities that must be coordinated with the project. After all, with any idea of completing something, there's a set of tasks that need to be done. We saw this with process management, and now we're seeing it again within project management. There's stuff to be done, and it's time to organize it. That said, projects generally are so large that in many ways they take a life of their own. Now keep in mind, a project, like most other things in this business, is a form of problem solving. So what's the first step of problem solving? Well, the first step of problem solving is determining what you want. What do you want? So we have to decide what we want. And that's the first step in project lifecycle, the definition step. We have to decide what we want, and the details of what we hope to accomplish with this project. And we have to see if we can actually do it. Well, once we've determined what we want, then we have to see where we are now. What's the current situation? So, what is the current situation? And then once we have that, we need to figure out how we get from where we are to where we want to be. And that's the planning stage. So we start looking at the details, all of the little things that need to happen to get this project done, to go from where we are to where we want to be. Well, once we figure that out, then we act. We go through the execution stage of the project life cycle. We complete the project. We get work done. We get stuff done. And then there's this last step. And what's going on here is that completing a project is not quite as simple as just saying, okay, we're done, let's go on to something else. It doesn't quite work that way. You see, you have these people who've been working on this project for all this time, and you're just going to say, okay, have fun, bye-bye. That doesn't quite work. Oftentimes, separating people from the project and equipment from the project can be an effort in and of itself. In fact, when we talk about MRP ERP systems in week 6 in the grab bag, we'll see that this is a case where getting people away from the project is a lot more difficult than it sounds. That said, it still needs to happen. You still need to move people and equipment and resources away from the project and on to other things. After all, while the project may be done, you still have to clean up. And much of these cases with projects, that can be the part that's oftentimes overlooked and oftentimes overestimated, or oftentimes underestimated. Cleaning up. Okay, so what does a project manager actually manage? Well, the project manager manages all of the different things that are involved with a project. Well, they manage, of course, the work. What needs to be done with the project? Well, people are going to do this, right? So you have to have some knowledge of human resources. You have to know who does what in this case. You need to be able to communicate well. You need to make sure that everybody's on the same page with the project. And also you have to make sure that this is a quality project, that the work done is done right. Now this can be important. After all, you don't want the roof caving in, right? So you have to be sure that the work is done well. Also, you have to be sure that each activity is done on time and on schedule, and of course, done within budget. So, the first thing we need to do is we need to break down, once we've decided we have the project, once we've determined what we want, well, then it's time to start breaking things down. Break down what needs to be done with regard to the project. So, a good way of thinking about this, and this is an excellent technique for problem solving, and that is that if you have just this huge project by itself, can you get it done? Well, probably not. You see, difficult problems are difficult to solve. They're in some ways impossible to solve. However, here's what you do. If you ever have a problem that is too difficult, you start breaking it down into manageable chunks, into parts that you can solve. So, what do? You break down the difficult parts into not so difficult parts. So you break it down into smaller items, smaller things done. So if I asked you to build a house, well, you probably couldn't build a house. But suppose I said, okay, we need to get the foundation done. We need to set the foundation. Well, you could either do that yourself if you're sufficiently skilled, or you would know to call somebody to get that done. So you break down the big assignments into smaller and smaller and smaller pieces until you get to things that people can address, that people can get done. And that's what a work breakdown structure does. It separates those large tasks into smaller and smaller tasks until only a set of manageable tasks are left, things you can get done. And next time, we're going to see how to take those tasks and organize them such that we see how to get the project done. With that, we're going to use PERT CPM. But that is for next video. Thank you.